Good morning, good evening, or good afternoon, depending on the time zone. I'm Tomohiro from the University of Tokyo. Today, I'd like to share my research on the asymmetric gravitational oscillation on fingertips, increase the perceived heaviness of a pinched object. The purpose of this study is to investigate a change in perceived heaviness when pinching an object. In our daily lives, we pick up things and touch them to understand their properties. Weight, temperature, stiffness, and so on. So here, I focused on the heaviness. Suppose you pinch a cup, how do we sense the weight of the cup? We usually feel how heavy the cup is from the information of the cutaneous and the muscle sensation. So in addition to them, other modalities also affect the sense of heaviness. Many studies have reported that the impression of an object heaviness changes. Since the surface roughness, the rougher is perceived to be heavier than the smoother one. The size, the very famous phenomena called the size-weight illusion, the smaller is perceived to be heavier than the larger one when lifted. The temperatures and the color, the brightness, also the change, the impression of the heaviness. In addition, the cognitive factors such as the experience of playing golf, called golf ball illusion, and also the semantic words to explain this object is heavy can affect the impression of the heaviness. So let's go back to the example of the coffee cup. When someone pours coffee into the cup, the weight of the cup increased. Then the sensory input from the finger part increases. However, even if the coffee is not poured, a specific vibration pattern applied to the finger part would increase the sensory input from the receptors in the finger part. As a result, a person who pinches the cup thinks the cup becomes heavier even if the actual weight is unchanged. So we have proposed to use an asymmetric vibration to create a force sensation of being pulled or pushed. Asymmetric vibration involves different acceleration patterns in two directions that create a perceived force imbalance. The average of the forces in each direction are identical, but due to the nonlinearity of human perception, only one directional force can be perceived. So we generated an asymmetric oscillation in the gravitational direction to modulate the heaviness perception. So I used a small, pinchable box which installed a vibrator inside. As shown in the animation at the center, our weight in the vibrator oscillates asymmetrically in the vertical direction. And the light graph shows the output of the acceleration. So I designed an experiment to quantify the amplitude of the perceived heaviness due to the asymmetric oscillation. The three boxes labeled A, B, and C were placed on the table, and the monitor in front of the participants showed which box should be pinched and picked up next. The participants compared the weight of a pair of boxes and responded by pressing a keypad with the left hand. An experimenter seated behind the monitor changed the weight of the weight pan for every trial. One trial consists of two lifts, one with the standard stimuli and one with the comparison stimuli. The standard is one with vibration. The comparison is one without vibration. The participants were required to pinch and lift the box in a precise and firm grip. On hearing a tone, participants lift the box vertically approximately 1 cm. After the 3 seconds, they place the box on the table. On hearing a second tone, they were instructed not to twist the box. After to lift, they pressed the button to indicate which box felt heavier. So I generated a psychometric function for the heaviness evaluation through varying relative gross weight of the stimulations. The left figure shows the mean proportion of the heavy evaluation for each stimulus, and the right one shows the representative subject. And the 50% point on the psychometric function was defined as a PSC, point of subjective quality. If the discrimination were not affected through the vibration, the PSE would be expected to the 50 gram. The results show that the significant PSE shift from the 50 grams in the asymmetric oscillation and the symmetric oscillation condition. So this suggests that the vibration increased a perceived weight compared to the static condition. So the PSE and the just noticeable difference called J and D, these values are calculated using the fitted function. So J and D is a measure of the weight change sensitivity. The results indicate that the PSE of the asymmetric oscillation condition is larger than the symmetric oscillation. This suggests that the participants felt the asymmetric vibration box was heavier than the symmetric vibrating box. On the other hand, this analysis showed no significant difference in the J and D between the asymmetric and the symmetric vibration conditions. So this suggests that the differences in the sensitivity of the weight perception between the asymmetric and the symmetric vibrations were not readily determinable. This figure shows the maximum grip force during the experiment for representative participants. There were no clear differences between the vibration and the static conditions. This could imply that the change in the perception of the heaviness did not stem from the changes in grip force. But the pressure sensor used to measure the grip force in the experiment could not detect any slippage at the fingertips. So a higher frequency of vibration may cause the stick and slip phenomena on the contact surface between the fingertip and the boxes. Further investigation will be required. Other studies on size-weight illusion suggest that there is a dissociation between perception and sensory motor. Right figures show the time course of the grip force of the first two trials and the last two trials. The grip force of the two lifts, the large box and small box, become almost identical after the 50 and 16 lift. But even at the time, the participant still did feel the size-weight illusion. So it means that the dissociation of the perception and the sensory motor exists. So let me summarize my talk today. We evaluated change in the heaviness perception due to asymmetric oscillation and examined the PSE of the amplitude of these changes. And our results suggest that perceived weight of a vibrating object increased compared to that of the static object. Moreover, an object vibrating with asymmetric oscillation led to an increased perception of the heaviness compared to that with symmetric oscillation, when a high acceleration peak was generated in the direction of the gravity. The future studies are required to examine the frequency and the amplitude of asymmetric vibration about heaviness perception. And these are the possible applications using the asymmetric oscillation. Using the change in the heaviness by the oscillation, a user can feel the sensation of the virtual fish nibbling on a hook and the weight of a virtual fish. Okay, so that's it. Thanks for listening.